So originally, Sarah Maxwell was going to be leading this session, and unfortunately, she's not able to join us this morning, but really she was the major impetus behind this and paper that she lead authored, specific to cumulative impacts and top predators in the California current. So that'll be the first talk, and I will be presenting on her behalf, so bear with. And then Carrie Capel's going to talk about some trade-off analysis approaches, and then I'll talk about how these cumulative impacts basically fold into the Ocean Health Index that Steve Katana eloquently spoke of last night at the keynote. And then Evan Paul from UCSD, who was involved in the Marine Life Protection Act stakeholder interface that really drove that process. He's going to talk about their latest tools. So hopefully this will just seed your heads for just really exciting discussion about how we put all this disparate information together in a way that sustainably and sanely manages our natural resources and our human activities. So we're just going to have a few more slides here to introduce some of the stuff. So as a reminder from one of Steve's slides yesterday, this question of which is healthier, just the pristine area without people, or still a sustainably used area with people, I think is the question. That is hopefully becoming much more apparent that really there's no place left on Earth that is untouched by human activity. So we really have to integrate that into our thinking of an ecosystem. And here's another image that has been, or a paper that's been referenced a few times already about global human impacts, and that's what this tells us. It's a little washed out, apologies, but even the lowest impact places near the poles are certainly heavily impacted by climate change and ocean acidification and changes of ice extent and timing. So, really there's no place left on Earth that isn't impacted. So we have to bring the people into the equation, and we also need to affect human behavior. So, and if we're going to do that, they automatically have to be part of the equations. Because we have these human activities that are potentially obviously dangerous, whether we're talking about pile driving wind farms or military activities, blowing things up, or doing ship shock trials, or lower mid-frequency sonar, or fish entanglements, or ship strikes. And these are all certainly issues relevant to marine mammals, and we have to integrate these threats in a comprehensive way. And so then we have to also think about all these jurisdictions, so different agencies that handle these. And Southern California is just such a right place to do this and to do this right. So this is from a Crowder et al. Paper, 2006, Science, that highlighted all these overlapping jurisdictions and human activities, and just integrating all this is quite a task. But we are making good progress. So that's a lot of what we're going to talk about. Wow, really washed out again, but yeah, cool. All right, so now hopefully you don't fall asleep with my drony voice and the dim lights, but we shall survive. So, this is, to me, just a massive success story that 15% of our nearshore environment has been protected with this recent effort that took effect in January 1st of 2012. And we're talking about a whole bunch of stakeholders that got brought into this process and an agreement made. So that's a good sign, 15% with this effort. So we can do this. And how can we do this best? And that's what we want to talk about today. So I'm going to start with Sarah's talk on cumulative impacts of top predators, and then Carrie, like I said, is going to talk about another 2012 paper with trade-off analysis, and then we'll revisit this, some latest, greatest with ocean health, and dive into a few more specifics than that continue on where Steve left off. His keynote, and then Evan's going to talk about some really cool interfaces for engaging with this type of holistic frameworks. So the other headshot I wanted to include here was Ben Halpern, because he really is either the lead PI or co-PI or co-author on a lot of these papers that we're really focusing on. So it's thanks to his ability to bring just a whole lot of great minds to the table and come up with something this, honestly, just outright audacious. When I first saw the science paper, I was like, whoa, somebody could do that? And even the Ocean Health Index is even more audacious. So I think that we should welcome this as, you know, food for thought, and there's always room for improvement, and we certainly aren't there yet. So I want us to really have a good discussion today about this. So here are a few questions that Sarah organized that, you know, I want to seed your heads with some of these things as we go through this, about like what kinds of roadblocks do we currently have with characterizing, I would even suggest implementing and managing these impacts. What data do we still need what impacts are we missing? What additional data layers do we need to cultivate in order to do this right? How do we get at something so global and broad and uncertain as climate change impacts in a way that we can locally manage? Are there other examples that you all know of where people have done this right with managing across these various stressors? And then what other tools do we need? What do you want in your toolbox to communicate this science to the public, to communicate amongst each other? And then because this meeting is really, we heard a lot of also from Brandon in South Hall about the impacts of sound in the panel yesterday. And I would like to have a little bit of discussion about what we need to integrate the distribution of sound, which is really exciting, what Mac Powell showed yesterday about a global soundscape that we can look at on the planet. And then we have these distributions of marine mammals. So how do we integrate those two? Can we multiply them out? Can we get there, guys, to identify sonic hotspots? Yeah, I just like the sound of that. And it sounds like a video game, Sonic Hedgehog, but it's Sonic hotspots. Anyway, so with that, I just want to thank certainly the hosts, the very generous hosts, Bob, Haskell, Tennyson, Baylor, and the Pacific Life Foundation for having us here, bringing us together. And again, this just wonderful laboratory that is Southern California, and with the aggregate intelligence in this room, we can be a light for doing this right. And also to Sarah Grosky, who helped rally our little panel and group, and I'm sure a lot of the other folks here in organizing, so thank you all. So with that, we're going to open it up to a few questions after each talk, so we catch things that are pertinent, and then we're going to have a larger discussion, similar to panels yesterday. So before I launch into Sarah's, I'll open the floor for any other comments or questions briefly. So, yeah. We'll all just carry forward. Okay, so really this work was, a lot of the folks here are from the Tagging Pacific Pelagics project, and they tag a whole bunch of animals. I mean, the largest telemetry database certainly on the planet for marine critters, and then sort of taking the distributions there, and then taking the work of Ben Halpern and that cumulative impacts that he did specific to the California current, and then meshing them together and really updating this with specific stressors specific to these top predators. So by top predators, obviously referring here to not only marine mammals, but seabirds and sea turtles. And maybe some other predators too, sharks and such. But so marine predators are obviously important ecologically and economically. So we have fisheries that they're important for, and they're obviously Steve Katona touched on their importance ecologically as umbrella species, keystone species, flagship species. So then they're important also for ecosystem-based management. They're even, especially with the tag data, they are biologgers, as they've also been called. They sense the environment. They tell us a lot about how we can manage all kinds of impacts. They sample elephant seals, deepest divers and below the sea ice, and they can inform our physical models about what's happening in the world, as well as our ecological models. And of course, they're regulated through the Mammal Protection Act, Endangered Species Act, and Bird Migratory Act. So understanding and really refining the work and how these things get regulated. There was some talk yesterday of thresholds and potential biological removal. So yeah, that's the backdrop. Okay, so here now we're talking about the framework. So there's an impact intensity. So how much of an activity are we doing, and where? So there's a spatial component there, and then there's the where of the species and where are they distributed, and then there's the aspatial information about how sensitive these species are to those given human activities. So these are really the three components that we need to then combine them to understand the specific cumulative impacts on specific to species, and then join them together. So we're in luck that we've got these components somewhat described, at least the spatial parts here, there was a Block et al. Paper. So Bart Block was the PI on the tiny Pacific pelagics, and there you just see the incredible journeys that these animals have undertaken in really sampling the vast ocean. And using their distribution, then you can associate them with the habitat and come up with these relative densities of habitats by species. And then on the right, we have the human footprint, really. And so that was from a 2009 paper specific to California current, where we have a finer grain of information on these impacts, because we're data rich. So in total, they looked at here for the species spatial component, 685 individuals from across 8 species. So really, as far as top predators, top program looked at other top predators, but here was the subsample in which they aggregated this information. And that missing component is that there was a lot of hard work, I know, on Sarah and co-authors' parts, was really mining the literature for the relative stress levels that these human impacts have on these given species. And this is something that I think it's great work that needs to be filled out even across many more species. So we'll get more refined with this approach, and then we put those together to get a cumulative impact. Okay. So here's an example of then the relative species use. In this case, it's aggregated across the turtles, the whales, or cetaceans, and birds. And then there's a laundry list of impacts, but you can also consider them according to these 5 major categories of climate impacts and pollution impacts, shipping impacts, fishing impacts, coastal impacts. And what you also notice is that we don't have sound impacts in here, so there's work ahead to do that. That's what we need to get this room organized around. So within those, there's a further breakdown of either UV radiation or acidification of climate. Then with shipping, you have ballast water that can introduce invasive species or shipping lanes. Pollution, we can break that down into organic, inorganic, coastal waste and nutrient loads. And then fishing, we have different fishing gears that determine different fishing types, whether it's trawl or with bycatch impacts or destructive habitat impacts. And so all of these and then we've got the impact intensity. So this is then looking at these cumulative impacts. And then we've got the species sensitivity. So this is this non-spatial component. And these are the measures that play into what the ultimate weighting is. So how frequent are these impacts? How direct or indirect, so on a population level, and how does that relate to actual mortality, and then recovery time then obviously interacts with frequency, and what's the overall reproductive fitness as an effect of these things, and general population effects. So this is the summary figure per taxon. We see per marine mammal, seabirds or sea turtles. We see the aggregate of these 5 major groupings of impacts, and certainly the one that is highlighted as having the biggest impact is among seabirds. The pollution component is the strongest. It's also the strongest for marine mammals and for sea turtles as far as total impacts go here. And then, say the runner-up for marine mammals looks like climate. So anyway, that's a pretty nice piece of work in and of itself. So then, how do we combine all this stuff to get at this cumulative? Which by cumulative sort of infers that it's additive. So this equation is it's summing across species and across impacts to then come up with this. And then, so you multiply the species times its cumulative impacts with the weights, and then you get you arrive at your final additive summary of total impacts. So what's interesting is that there's this habitat use that's on the continental shelf and in the national marine sanctuaries, and that's where we see greater habitat use than offshore. And the stressors are also greater. So we've got this combined effect where we've got more stress and more use by the animals in the same places that are near shore, which also correspond to the national marine sanctuaries. So that means that we've got, it's just an additive effect. So again, it's pretty high in these national marine sanctuaries. And the offshore pattern is not as consistent on the shelf. So as far as the stressors, the 90% of the stressors are on shelf, and there's about 50% that are off shelf. And then when we add those up, then 81% of the core cumulative impacts, where we have basically the hotspots of the stressors interacting with the habitats, are on shelf. You know what? That might need some revisiting. A great way to characterize a talk is that it's an advertisement for the paper where you dig deeper. And honestly, I felt like I did a fairly shoddy job of explaining that. So I know that they submitted to Science. Unfortunately, it didn't get accepted there, but it is forthcoming in another, I'm sure, high-profile journal. So my apologies to Sarah et al. So So here we see these, the different influences of these different stressors. So pollution has a high impact on seabirds and not as high, for instance, on sea turtles, and marine mammals is not. So different stressors have different impacts, and that's the take-home. So where can these, that's really, in the end, we're needing to understand how to strategically manage these activities in time and in space. So where can we conduct human activities that have these potential impacts and do it in a way that does the least amount of damage? That's really why we're doing this. And can we also, just do it in a way that minimizes the area that we identify for need of management? So if there's a concentrated hotspot, can we bring that down and then have an overall greater impact by identifying these areas of conflict? And then it helps us grapple as far as what's local versus large scale, what's evenly distributed versus highly localized. So, so this suggests that that the cumulative impacts, it can be fairly localized. So when we look at, for instance, the impacts of fisheries on cetaceans, there is this little hotspot that pops out, and that attracts attention in the middle panel in red. So that hotspot, so that attracts attention to where maybe a time area closure is most effective. Or we could use, especially with seabirds, some bycatch reduction devices in sea turtles. So how can we do some gear modifications in order to minimize these impacts? And then there could still be these micro-refugia, even to address something as global as climate change, that we could also further protect from the cumulative impact of other stressors. And even with some protection in place with the national marine sanctuaries, they still seem to be areas of high cumulative impact. So how can we cordon off some of these impacts in the spatial way? So additional data types are needed. We need to have, there's survey data. These habitat use maps were based off of telemetry data that can be brought to play. Certainly understanding the relative stress, the stressors from not only species level, but then beyond that, we've got, there could be differential impacts at different ages or sex of these species, and then understanding the time and space component both for the stressors and the species distributions, and then getting at really the population dynamics impacts. So I'm just going to leave this slide up for acknowledgments, and thank you for your patience with the talk that was very, very nicely put together by Sarah, and stumbled a bit. But I'm going to open it up to questions, and I wouldn't expect really insightful answers. But maybe there's other people in the room, and certainly we'd like to relay specific questions back to Sarah and the rest of their group. So yeah, thank you. Yeah, John.
I think I've asked this a few years ago and I forgot the answer to it. Tag data, I know, is the concern with tag data and analyzing these sort of spatial things is often it's so influenced by the location the tag was deployed.
That's
very
right.
different results, and I'm kind of familiar with specific species data sets and that other. For these kinds of analysis, do you know how that was addressed?
Wow, shoot.
Because I know, I think a lot of those deployments occur at very clustered locations. Deployment,
Yeah.
when you average them all together for the different species, you address it to some degree, but within a species, they can often be very affected by deployment location.
Yeah, so I'm going to try that one, and then I'm going to open the floor if anybody else has some good responses. So certainly with the coincidence with the the near-shore habitat use and the fact that these animals are generally tagged near shore, you would tend to draw this conclusion that, you know, there's a bias in the tagging location. But I think that they limited the animals that were used and the individuals that were tagged and their tracks to a certain number of days that then provides a fairly large swath of their pelagic time spent to not only areas, as you saw with the first top image, of nearshore use, but also offshore use. And because this is a animal following track, that I think part of the idea is that there's enough time spent with the tracking device to capture that offshore component if it is part of the regular habitat use. And then it's a matter of then relating that. I think it might have even chopped off the initial few days after the tagging event and then used later days. But I don't know. Does anybody else have anything to add to that? Okay, but good question, and I will refer Sarah back to a fuller response. But yeah, question in the back.
It seems like most of the species were migratory species. Is there any plans to look at more resident or less migratory species?
Yeah. I'm not sure what the plans are with, and top was definitely, as far as the telemetry project, it focused quite a bit on these migratory animals because that's where the interesting dynamics are. And I think that just getting that more fleshed out with that stressor weighting, understanding on a per species level, especially for the residents, is a really good point. So I'm not sure of other plans with this work to continue on that fashion, but I agree that's where we need to go. It's a good point. Yeah, Jeff.
So the real kind of black box in this to me at this point then is that, you know, there was the slide that sort of ranked the relative importance of different types of stressors.
Right.
For example, the statement that seabirds are most sensitive to pollution impacts.
Mm-hmm.
I mean, I feel like, you know, I don't feel like we really have a good understanding of that, of which of those types of stressors really are the most important. We might have measurements for some species of pollutant loads, for example, but we don't know in many cases what the impact of that really is. We don't know.
Right.
We've heard a lot about sound impacts. We know that there are some behavioral consequences, for example, of different types of sound. We don't obviously have a good sense of how that really scales, like what the real consequences of those are. So to me, that ranking exercise of threats, of impact of different stressors on different taxonomic groups is, you know, often dictating for the paper and see how they treated it. But that's maybe, I'm a bit skeptical of that at this point.
Right.
So that might be a comment for Sarah, or maybe you can field it.
Yeah, I'm gonna defer the deep innards of that response to Sarah. But I think that, you know, it brings up this question: do we deal with some level of uncertainty and speculate as best we can with our aggregate understanding, or do we wait to even begin to quantify this until we have absolutely certain information? And that's sort of this tug between management and science, and you know, management needs answers sooner than later. And so maybe we give it our best shot with plenty of asterisks that highlight the caveats, and hopefully we improve that, you know, that black box of those weightings with a more fleshed out understanding and identify gaps. I mean, for instance, even with seabirds and plastics, I mean, they autopsies on these animals, or even sea turtles, find so many plastics inside, but it's really hard to quantify mortality and show the direct impacts of that this ingestion of all these plastics actually has on the birds and the turtles. But it's obviously impacting them. We're having trouble understanding the actual specific number. So does that mean that we shouldn't include it in this comprehensive framework? And I guess I'm of the mind that we should include it and do the best job and refine as we go.
I agree with you.
Yeah. But yeah, good comment. Yeah, Carrie.
I might just add a little bit of detail on what I think they did. So they tried to parameterize those vulnerability measures using what was available in the literature, and they had like 5 different factors that were the components of vulnerability and a categorical scale for each of those that they tried. So they tried to assign values like from 1 to 4 for each of those based on what was in the literature. So that's it will certainly be vulnerable to the gaps and uncertainties, things that have been studied well versus things that we just don't know very well what the impacts are. And I'm not sure how they treated that uncertainty. But I think they did have a way to at least assess a way to assess uncertainty in those measurements or those estimates. But it's really kind of a literature review-based expert opinion done by the authors. When we've done these cumulative impact assessments targeting ecosystems rather than species, we've turned to experts to give us those vulnerability scores as well, knowing that there isn't a lot of empirical information about all the different possible combinations of stressors in ecosystems. With species, in some cases you have more information, in some cases less. So there are a lot of gaps.
One more question, and then we'll let Carrie get a few percent. Yeah, please.
So if this hasn't already been done, is there a way then to ground truth the areas that have been recognized as higher risk, lower risk, of comparing, looking at similar populations living in these different areas? Of course, it's not the migratory ones would be harder, but then to look at the health of the populations living in these hotspots are actually, are worse than those living in the.
Yeah, that's a wonderful idea. Yeah. So how can we actually get at measuring and doing a little ground truthing with some of these sort of black boxy weightings of stressors on just specific species by picking maybe from a spectrum and seeing actual impacts? That's a great idea.